The concept of the end of the universe involves several speculative scenarios based on our current understanding of cosmology, physics, and the evolution of the cosmos. It's important to note that these scenarios are theoretical and subject to ongoing scientific investigation. Heat death, entropy death. 1. One of the prevailing theories is the concept of heat death or entropy death. 1. This scenario is based on the second law of thermodynamics, which states that entropy, a measure of disorder or randomness, tends to increase over time. 2. In the context of the universe, this suggests that the cosmos is gradually moving towards a state of maximum entropy, where all matter and energy are evenly distributed and there are no more gradients for thermodynamic processes to occur. 3. In a heat death scenario, temperatures in the universe asymptotically approach absolute zero and all physical processes come to a halt. 3. Stars burn out, galaxies drift apart, and the universe becomes a cold, dark, and lifeless expanse. Big freeze, expansion forever. 1. The idea of the big freeze is closely related to the concept of heat death. 1. It envisions a scenario where the universe continues to expand at an accelerating rate due to dark energy. 2. As galaxies move away from each other, the space between them expands. 2. This leads to a dilution of matter and a decrease in temperature. 3. Ultimately, stars run out of fuel, and the universe becomes dominated by cold, dark remnants such as black holes. Big crunch, contraction of the universe. 1. In the past, scientists considered the possibility of a big crunch, where the expansion of the universe would eventually reverse, leading to a collapse of the cosmos back to a hot, dense state. 2. However, current observational evidence, including the discovery of dark energy, suggests that the universe's expansion is accelerating rather than slowing down. 2. This makes a big crunch less likely based on our current understanding. Big rip, extreme expansion. 1. Another speculative scenario involves the idea of a big rip, where dark energy becomes more dominant over time, causing the accelerated expansion to increase to the point where it tears apart galaxies, stars, planets, and even atoms. 2. This scenario is considered less likely based on current observational data, but it remains a topic of theoretical investigation. It's important to emphasize that these scenarios are based on our current understanding of physics and cosmology, and new discoveries could influence our understanding of the fate of the universe. Additionally, the timeline for these events is extremely long, operating on cosmological timescales, and the ultimate fate of the universe remains an open question in scientific inquiry.